This part is about the plotting on a map, and basically it is handled by this big function called the display nodes. So actually it contains a lot of sub steps. So in addition to this function, there are also a couple of supporting functions. So we're going to go through that part by part. So the first part is to deal with the cutoffs or the categories of data. So on a map, we're going to represent, for example, the number of confirmed cases by a circle. But we need to, we're going to represent the number of cases by the size of the circle. But we cannot do it in a continuous scale, because otherwise, imagine that for some places like in Wuhan, the cases are like 2,000, 1,000-ish, but in some of the places there's only one. So if it is in a continuous scale, then some of the circles are too small, and some will be extremely large. So it is for that purpose we have to make that into categories, which is basically the cutoffs. For example, here that if the confirmed case is less than 1 and 1 or less than 1, it would be like here. And then actually I should change that. This should be 1. This is 2 to 4. Then 5 to 15. Then 16 to 93. And then 9 to 94 plus. So, but how to determine these categories? In different time point, we have different distribution of the cases. So we will need a function to set a cutoff. Basically, it is to put these numbers into different categories according to the cutoff. So because of the data is quite skewed, so we cannot even use a normal quintile approach. So what I have here is that I'm gonna talk about that later. Anyway, so to do this, the first is that we're gonna have the most recent data. So imagine that on this map you can see that for one place, like in Wuhan, for example, or the other places. So okay, so let's see this example, like for Hangzhou, there are 2 circles. One is smaller. Actually, there are probably 3 circles. One is very small, one is larger, and the other is larger. So this is because at first there are very few number of cases in Hangzhou, and the circle is smaller. But then later, because there are more cases, so there is going to be a bigger circle. So now actually this is a mistake on error, because when I first built this map, I didn't take into account this, and the circles repeatedly appear in this map for the same place. But later I found that actually it's not a bad idea, because on this map and now not only we can see the current size in terms of the confirmed cases, we can also see the historical change in terms of the case. So I'm going to leave it there. But anyways, so to determine the cutoffs for each time point, we need to have the most recent data according to this time point, and the cutoff should be based on this, because otherwise if you have all the historical data, then like the numbers for Hefei or Hangzhou is gonna repeat for many times, then your cutoff is not correct, because it is affected by this repeated measures. So the first thing we're going to do is to have a function called getRecent to have those data points of each place, but this time it is of the most recent reporting time. So this getRecent is quite complex. It is actually in the customized macros, and we're going to talk about that later. Anyways, the idea is that we're going to have the most recent data for each place. And then based on the recent data, which contains everything like the confirmed case, the number of death cases, the place, whatever. So from these data, we're going to obtain the confirmed cases and put that into a collection, which is called the recent confirmed. So based on that, then we're going to use a macro to get the cutoff. So basically, the macro of cutoff is here. It is to use the mass package and use the function called the quintile sequence to have the cutoff. Now, earlier I've mentioned that because the data is quite skewed, so the cutoff I applied is like this. So the first, that any points below the 50% quintile will be in one category. The second is those between the 50% and 80% quintile. And the third is the 95 quintile, and then the 99 quintile. Basically, I'm going to put it like this. So this is going to cut the data into 5 categories. One is below 50%, the other is between 50 and 80%, then 80% to 95%, and 95% to 99%. And finally, those above 99%. I also set a error control. So if the data, for example, there is not enough categories for all of these 5, I'm going to return the collection of 99, which is to indicate that there is some error in this cutoff. So this function is going to take a collection of A, which is to confirm the cases by each place. All right, so imagine that it would be like in Wuhan 1000 and Hangzhou 100, whatever. So these are the collections of confirmed cases. And the output from this function is also an array or a collection with 4 points. And basically these are the cutoffs. For example, it is going to say that, well, if the case is above 2 to 9, then you put in the second category. All right, so this is one cutoff here, one here, one here, one here. So there will be 4 cutoff points. This is the output from this function. So with this cutoffs, and then the next is that we can have all the bounded number of cases to the nodes, and to determine what is the category it should be in. Like should it be in the category of like in this case 10 to 39, or in the case of 40 to 330. So we're gonna have all the nodes and have the data. In this data there will be so this part is to deal with the legend, to update the legend. So now we have the cutoff. Basically these are the 4 numbers from this function, this output of this function. And with that we can update the legend, which is here. So now because we have the cutoffs, and then we can have the legend, which are these numbers, these ranges, and put it there. And basically this part is deal with that. Okay, so in this case the legend in terms of the confirmed cases are going to be updated for different time point, because the number of cases are changing. You can see that once when we slide the handle, it is going to show different range of cutoffs. Well, the next part is to add nodes according to the number of cases. So this part is quite straightforward if you are familiar with D3. So the first is that we're going to bind the data to the G points. Um, so the next is that we're going to apply a pin, we're going to add the circles, and the size of the circle is determined by the number of confirmed cases with the cutoff, which is like if it is above 2, then it's category 1. If it is 2 to 8, like it's category 2, whatever. So the cutoff. And then based on this, we're going to determine the size of the circle in terms of radius. And remember, so we have the number of cases from this data. We have the cutoff from the function above, and we have the categories of the radius defined in the initial period. So in this case, we define that the radius category is as 5. So now these three things can be worked together to determine for a particular data point what cutoff range it belongs to and what radius it should be displayed on the map. That is done by a function called rcat. Is it cat r, basically to categorize the r of the radius. So I also have a bunch of different versions of r cat r functions, but the latest one is this. Well, the next is applying the same idea or concept, but this time is to deal with the number of diseased cases. So again, we're going to have the most recent data, and we're going to apply a cutoff again, but this time we're going to have a different categories. Instead of 3, we're going to have instead of 4 cutoff points, this time we're going to have only 3 cutoff points. And then we're going to have a function again to deal with this category, and turned out that despite it is called R, but this time it is a rectangle. Actually, it is to determine the side or the width and the height of the rect. Well, initially I had the idea of applying this get cutoff to by different categories. But then I think later I changed my mind. I just use a fixed categories and instead of using that, because the death case is quite small. There is no need to dynamically change it, or even if you apply that, it is not going to change much. Well, the next part is to append regs representing the death cases. And then use the function. Sorry, I have to say that again. So it is complicated, and sometimes I myself get confused. So this cat3 is to determine the size of the rectangle. But for this category, I didn't use this cutoff 2. Instead, I used a fixed categories. But anyways. So this part is to deal with the rectangle, and the width and height is determined by this function called cat rectangle. Basically, it's the same idea to have different categories. So now we have the circles and the rectangles on the map, but they are all at the starting point, and the starting point of this G is here. So all the circles and the rectangles are placed here. So the next part is to update their positions according to the GPS coordinates provided. So the GPS coordinates has been treated and put into an array called latitude, longitude. So this part is that according to their latitude and longitude is gonna place these nodes in the proper point. And this is achieved by the module provided by Leaflet. So that one will take into account that if you are increase or zoom in or zoom out the map area. And actually, that part is quite complicated. I think there is a video. I can't remember the source, but maybe you guys can search it. It is talking about how to deal with this zooming and zoom out. So bear in mind that it is not a, how to say, it is not a plane. The map is actually is part of a big sphere. And remember, because our Earth is round, right? So when consider zoom in and zoom out, you have to put in a paradigm that you are dealing with the surface of a sphere or a globe instead of a plane, a plane surface. But anyways, so this part is handled by the leaflet, and by using these functions, we can update their positions according to the current zoom in and zoom out. And this is done by this function called update nodes. All right, to this point, I want to say something about this update. So there are different things to update here. And in different examples, you might see different update functions. The first is that in the old D3 examples, it is always have a function called update. And that update is basically to update the number of nodes to be put on a on a map or on a G component or whatever, or on SVG. So that part, when it says update, it means that how many number of data points you're gonna have and how many, and according how many to be displayed there. So that is the D3 update. The second update is in Jane's case. It is basically talking about the update of the slide points, because the slider, when you change the position of the handler, or you are playing that, or when the handler is traveling, then you need to update the times and also the data. So this is the second part of the update. And this third part of the update is to update the positions on the map, which is handled by this leaflet functions or modules. So these are different concepts. So here, the update is for the third one. So they can all be called update, but actually they are for different purposes. So anyway, so then after this, actually I should move it above. So with this function and with all the nodes and rects put here, and the next is to run this function to update their positions. Yeah, so I'm going to put it here. So actually this part can be moved, can be put into the macros, so to make this part even better to read. But anyway, I'm going to leave it here for the time being. So the next is to set a function to listen to the map changes. This is basically that when the zoom is down, the zooming action is detected and is down, then we're going to update the nodes for their position. So basically it is to listen to those zooming actions and update the positions of the nodes on the map. Okay, so the next one is to clean up those excessive nodes, which is the exit function. But before doing that, we need to count the binded data here. So I've tested that, and it sounds very strange. I didn't figure out why, but it seems that I cannot put this part before uh, before um, uh, in the beginning. I mean, before this, yeah, before the G's and no G's. I cannot put it before that. Um, for unknown reasons that I didn't figure out, it will cause error. So if I put it there, then the points on this node map won't be changed according to the zooming action. So I have to put it here. And basically, what I did here is that it is going to recount the number of nodes we want to put on the map, give them an ID, and then to exit or remove the unbounded elements. Okay, so that is the main function, which is called the display nodes nodes on the map. So there are other functions that it will work for plotting the nodes, but we're gonna talk about that later. Well, like I said, all of these macros and modules are not put in a perfect order, so there's still a kind of jump. I'm gonna clean up later, but hopefully that I've explained all of them so that I can remember, in the future if I'm gonna improve it, I know where to dive into. But anyway, so now we're gonna talk about the final one, which is the master control of this program, which is called the main.js. So basically, what it does is to load the data. And that's it. So it is put in a async environment. It's gonna load the data and make the following changes here. So what it does is that it's gonna read the data. So I have two options. One is that I can read the data from a local JSON file, and then do the rest. And that part will require the async method. Well, what is an async method? So async, yeah. So basically, you can Google that, and the whole idea is that loading a data is going to require time. So basically, async does is that it's going to wait until this loading is complete and then carry on for the following actions. So without this, the JavaScript is not going to wait for the loading of that. So it is going to cause errors. Okay. So this is for the async. So the whole part inside is basically means that it's going to load the data and wait until the data is loaded, and then it's going to carry on for the rest of the things. But here I have an option here, which is this. So basically, you will see that in this case, I didn't use the local file at all. So instead, I'm going to call a macro, which is called get real data. And I just cheated a little bit because in this macro, I've injected the JSON file there. If you go to the macros, you can see that I have this function called get real data, but actually it is a JSON file. It put the JSON file there. It is gonna return or output the JSON file. Okay, so that's what I did here, or whatever. Is that a JSON file, a data array? I think it is a data array, but anyway, you get the point. So so you get the idea, right? So anyway, so I'm gonna read the data here. So actually, this function, it is flexible. So now we have two options. One is that I can read the data. The other is that I can call a macro and get the data directly. And now I'm taking the second approach in this example. So anyways, so this collection is supposed to be in a JSON format. So it is going to have the field which is called object, and inside there 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 is an array. This object contains an array of data points. So the following step is to define the data set using the data array from this JSON file. So once I have that, the next is to remember that we need to obtain the GPS coordinates and put that into a field called the latitude, longitude here. So basically it's gonna put that into a collection, into an array, and put that into this latitude and longitude. And also I'm gonna have a field called the time because the original data are actually strings in this format. I'm gonna change that using this moment function to change that into a time value. And finally, I'm gonna have a data ID for this, and basically this is to use in the D3 when adding the nodes and when binding the nodes. So you can see that despite that it is called a main function, so actually I did nothing here. I just load the data. There is nothing to do with plotting the data, right? So if I only run this project, it just load the data, but it does nothing to plot the data points in the map. So now, so because of this, as I said that these programs are not arranged in a perfect order. So now I have to go jump back to that map plot again, because the real actions for plotting is triggered by the functions other than this main .js. Well, it is for this reason that at the first when the page is loaded, there is nothing to be plotted on the map. There are two ways that you can trigger the plotting actions. The first is that you can press down and hold this handler. So as the handler is moving or traveling on this line, it is going to trigger the action of plotting the nodes. The other is, of course, you can hit the button, and when hit this button, it is going to automatically travel, and it is going to trigger the plotting actions. So these are done in by these two functions. One is called the play button. The other is the slider call. So for this one, it is that when you start in drag, is going to do something to update the plotting. So basically, that is achieved by this function called the slide update, and we're going to talk about that later. Well, so first we're going to talk about this interrupt and drag, and basically this represents a function of dragging the handle and to interrupt and drag the function and drag the handler. So basically what it does is that it is going to run this function called slide update, and before that it is going to determine the current value, which is the value of this handler, the x position or x coordinate of this handler. So how does it change that? The first is that it's going to remember the current value of the x coordinate of the mouse. So this D3 event x is to obtain the x coordinate value of the mouse. Well, actually, I've noticed that because of this, or I'm going to talk about later, there is a bug here in the original code that I made. So I'm going to have this position. So Next is that it's going to run a function called the slider update. So the slider update is basically going to do the following. The first is that it is going to assign the position of the mouse to the position of the handler. So basically to say that, well, if you have a mouse click, you're clicking here, then I am going to assign the x value of this handler and let it move here. But note this, so when I click here, the mouse, see that the mouse position is here. When I click on it, the handler actually moves a little bit far away from this. And this is a bug I need to fix later. And basically because the whole things in this SVG has been transformed for like 10 pixels, so that at the beginning, this handler won't only be covered for half, right? So imagine if there is no transform here, then only half of the circle will be viewed here, will be seen here. So because of this transform, then now there is a discrepancy between the mouse position and the handler's position. So that's why there is a bug here. I need to fix that later. But anyways, so it is gonna be close to that. It will change the position of the handler, and then it also going to change the position of the label, and also it is going to indicate the time of the label using this format function. So basically it is going to, once you click here, the handle is going to move here, and also the label is going to move here, and the corresponding time of this label is going to change. Right, so that's how it is achieved. So once that part is done, the next is that it is going to filter the data. So the new data will be only part of the original data set. And the filter is that in this data there is a time, and that time should be earlier than the current time point. So the current time point is here, and all the data before this will be filtered in, whereas all the data after this point will be discarded. So that's how it does here. So now we have the data until this point to be displayed, which is the data covering this period, and all of these data will be plotted on the map using this function called the display nodes. That's how it is achieved. All right, so this is the first way of triggering the plotting, the map plotting actions. The second is by hit this play button. So it is going to be a toggle. So once it is clicked, it is going to check. So if the original text is paused, which means the original situation is paused, then so what does that represent? So if the text is paused, that means that when it displays the pause, that means that the handler is traveling. Actually, it is playing, right? So that's why it is displayed as pause. All right, let's just do it again. When it is displayed as pause, it is playing, right? So in this case, when you click that, it's going to switch the text to play, and actually it's going to stop the playing because, you know, when it is displayed as pause, it is playing. So you click on it, it is going to pause the playing, which is stop the playing, do nothing, and just change the text to play. On the other hand, when it is not displayed as pause, and then it is displayed as play, which means that it is not playing at this moment. So in this case, when you click the play, it is going to start the play and change the text to pause. Okay, so if it is not displayed as pause, which means it is not playing, and then it's going to start the play. When it starts to play, it is going to define the following variables. The first is that it's going to tell the program that the moving is true. The second is that it's going to call a function, which is a built-in function by D3 is called the set interval. The set interval actually is going to call a method, which is called the step. And also it is going to apply the speed, which we have determined here. So last time we said that the speed of playing is that per step, it is going to take half a sec. So basically these are the parameters and the method to be determined, to be assigned for this method. And this is a built-in method by D3. So finally, this is to change the text to pause. Anyway, so the core to trigger the action is this built-in function called set interval. And it is going to call a method called the step and apply the parameter for speed we've defined in this initial variable. So in the step method, which is defined here, and what it does is that first it is going to do the slide update. So again, this is the same trick we've already discussed before, we've already introduced before, which is to update the handler position, the label, and then to filter the data and plot them on the map. Right? So this is what it does for the step. But not only about that, it is actually a recursive action. So it is going to display the plots, but it is also going to calculate the current value by adding the distance per step. All right. So now it is preparing for the next step. So it is going to add the distance to that. And now the distance says the current value of the distance has changed. And as long as it does not reach the end, which is the target value, which is defined in the beginning part of the slider.js, the target value, which is the end point of this timeline. So as long as it is, it does not reach the timeline, the end of the timeline. So it is going to keep playing. So this function, well, it is not stated here, but actually it is a recursive function that is going to constantly run that. The only exception is that when the current value travels to the end, or is greater than the end of the target value, which is the end of the end of the timeline. So only when it exceeds the end point, then the move is going to be stopped and is going to clear up all the timers and the values, and then it's going to return the play buttons text to play. So this is the second way of plotting the data. So basically you're going to click the play button, and if it is if the button is triggered, and it's going to call the function called the set interval. Basically it's called a function called step, and in the step it is going to update the current values, and it is going to constantly do that until the end of the timeline. And that's it. That's how this function does.